Hello friends, this video on thermal properties of matter part 3 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched part 1 and 2 before going ahead with part 3. Temperature is measured using a thermometer, right? Thermometer is something which you use even if not daily, but at least when somebody in your house gets fever, we normally measure the body temperature using a thermometer, right? So you all are familiar with how does a thermometer look like. Something like this, right? So it is basically nothing but a glass tube which is filled with a liquid, right? And there are calibrations or readings. Now as soon as you put the thermometer in your body, keep it for some time and then you observe the reading. So that reading gives you the temperature of the body. Now, what is the basis of thermometer construction? That means, what is the principle behind the working of thermometer? Basically, the fact or the principle that lies behind the functioning of thermometer is that volume of a liquid varies with temperature. That means as the temperature increases, the volume of the liquid also increases. Similarly, as the temperature decreases, the volume of the liquid also decreases. Now, just think how it actually works. Inside the thermometer, there is some liquid, right? Now, when you place the thermometer on an object which is hot, what happens? The temperature is more, that is, the temperature of that object is more. As a result, the liquid which is there in the thermometer, it starts expanding. So, the liquid starts expanding and as a result, the reading of the thermometer changes, right? Similarly, if you place the thermometer on an object which is very cold, in that case also the liquid will start contracting and again the reading on the thermometer will change. So, basically, the principle behind thermometer construction is that the volume of a liquid varies with temperature. Mercury and alcohol are commonly used liquids in thermometer. Now, why mercury and alcohol alone? Why can't we use water? There might be a question in your mind that if we just need any liquid, so we can place water instead of mercury. So, why not water? There are various reasons. For example, if you compare water with mercury, what do you see? If water is placed in glass, water sticks to the glass of the thermometer. Now, if the liquid sticks to the glass, it will not be freely moving through the tube. Whereas, if you think of mercury, it doesn't stick to the wall of the thermometer. As a result, the mercury liquid can move to and fro without sticking to the walls. Right? So, all such reasons have found that mercury is the most suitable liquid for thermometers. However, alcohol is also used in certain thermometers. But normally the thermometers which we use in our home and all, there we find mercury to be used as the liquid. Now that we have talked about what is temperature, what is heat and how do we measure temperature, let us look at the different scales of temperature. That is, when we measure temperature, so we will look at the scales of temperature. The reference points for measuring temperature, that means there are certain points which are taken as the reference points or the fixed points to determine the scale of temperature, so that even though there are different scales of temperature, they all are equivalent or they all are universal. So what are those two reference points for measuring temperature? One is ice point and the other one is steam point. So we define any scale of temperature with respect to these 2 points, ice point and steam point. Ice point is nothing but the freezing point, that is the temperature at which pure water freezes. So what is ice point? Ice point is nothing but the freezing point. Freezing point, that means the temperature where pure water freezes. And what is steam point? Steam point, as the name suggests, it is nothing but the boiling point. That is the temperature at which pure water boils. So these are the two reference points based on which different scales of temperature are defined. Now, what are the scales of temperature? The first one is the Celsius scale, where the ice point is 0 degrees Celsius and the steam point is 100 degrees Celsius. The second scale is the Fahrenheit scale, where the ice point is 32 degrees Fahrenheit and the steam point is 212 degrees Fahrenheit. What does this show? This shows that the ice point and the steam point in case of Celsius scale is 0 and 100, which shows that if you look at the scale, there are 100 equal intervals. That means the entire scale is divided into 100 equal intervals. The starting point being the ice point and the terminating point being the steam point. Similarly, the Fahrenheit scale, it is divided into 180 equal intervals, right? So in the Celsius scale, we have 100 equal intervals. Whereas in case of Fahrenheit scale, we have 180 equal intervals. Right? So we can have a comparison between the Celsius scale and the Fahrenheit scale. Now just look at this figure. The thermometer on the left hand side is calibrated as per Celsius scale, and on the right hand side is the Fahrenheit scale. If you see, the starting point or the ice point for Celsius scale is 0 degrees Celsius, which is equivalent to 32 degrees Fahrenheit. Similarly, the 100 degrees Celsius, that is the boiling point, is equivalent to 212 degrees of Fahrenheit. The only difference is that between these 2 points, between the ice point and the steam point, the number of intervals in case of Fahrenheit will be more than the number of intervals in case of Celsius. Now, how are Celsius and Fahrenheit related to each other? The relation that joins them is Tc by 5 is equal to Tf minus 32 by 9, where Tc is the temperature on the Celsius scale and Tf is the temperature on the Fahrenheit scale. Please remember this relationship because this is going to help you in long term. As I told, Tc is the temperature in Celsius scale and Tf the temperature in Fahrenheit scale. Now we will look at the graphical representation of relation between Celsius and Fahrenheit. That means, just now we saw that Tc by 5 is equal to Tf minus 32 by 9. So how can we represent it graphically? Let us say we have the Celsius scale on x-axis and we have the Fahrenheit scale on the y-axis. Now, what is the expression that we have for the relation between Celsius and Fahrenheit? So, what is the relation that we have? It is Tc by 5 is equal to Tf minus 32 by 9. So, this we can write it as Tf is equal to 9 Tc by 5 plus 32. Now look at this equation very carefully. Does it resemble to some common equation? You remember the equation y is equal to mx plus c. So what is y here? On the y-axis we have Tf, that is the temperature on the Fahrenheit scale, and on the x-axis we have Tc, that is the temperature on the Celsius scale. So Tf is our y and x is our Tc. So here, what is y is equal to mx plus c? This is the equation of a straight line. Now, since this relationship corresponds to the equation of a straight line, that means if we show graphically, it would be a straight line that would relate the temperature in Celsius and Fahrenheit scale. So, it says that m is M denotes the slope of the line and C denotes the intercept on the y-axis. So the slope is 9/5 and the intercept is 32. That means it would be a straight line and it will not pass through the origin. It has an intercept of 32. That is, there has to be this intercept. This intercept is C. So this would be the plot. So that means this determines the intercept, that is C. And the slope of the line is M. Slope is nothing but tan of theta. If this line makes an angle theta, then slope would become tan of theta. So what do we see here? Here we see that how do we graphically represent the relation between temperature on Celsius scale and the temperature on Fahrenheit scale. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.